Cool. All right. So let's talk about the identification component of the organic exam. Just so that we are aware of what we're working on our checklist, we are looking at number 10. I can explain how I would identify different unknown organic molecules. So I'm just taking that one off. And when it comes to that question, I'm just trying to see where it is. Here we go. All right. Just so you guys are aware of the achieved, the merit, and the excellence when it comes to that identification process. The achieved is just being able to list the reagents required and your observations. So it's kind of like baseline information. The merit is being able to explain how you're distinguishing the two. So actually comparing, contrasting the two molecules or the multiple molecules that you're identifying and stating which one's going to be positive for that test, which one's going to be negative for that test, that sort of thing. And then the excellence is going to be able to do multiple compounds, link it to the observations and the reagents to the species produced. So looking at just making sure you have all the I's dotted and T's crossed kind of thing. So that's what we're looking at, is that row there. And what I'll do is like I said, I'll do an exam question and we'll look at the marking schedule so we can see how the points broke down. When it comes to the, what's the word I'm looking for, audit of the questions, I'm just trying to see. Let me backtrack. One of the tricky things about the organic chemistry exam is that you have to memorize all the different reactions that are occurring. And these are going to be asked in two different contexts. The first context is going to be looking at, can you identify the molecule or can you distinguish the molecule? So that's the first kind of line of all the different identifications, or sorry, all the different reactions. And then the second reason why you're going to need to know all your reactions is being able to convert from one molecule to another and do like a massive flow chart. That's going to be the topic of next week, and we'll spend a little bit more time on that just because it takes a while to kind of learn the different reactions and how to get from one molecule to the next. And this one's frankly the easier of the two. So we are talking about the different types of reactions at a very kind of basic component, but we'll do that in more depth when we do the conversions. So I'm not taking that off right now, but we are looking at things like knowing amines are basic, amides are neutral, esters are sweet smelling. So these are all like identification things. This one's the aldehyde and ketone. This one's talking about color changes with the types of alcohols. This one's talking about the bromine water. This one is the carboxylic acid identification, the acid chloride identification. And I think that's it for the identifications right now. Looking at that, see what's on the next page. I think these are all conversion questions. All right, so this section here is just showing you all the different identification questions. Basically, all the different functional groups are fair game, but you can see that every year they ask that question. They just use a different combination of functional groups that you have to explain the identification of. So you can see in 2021, they did the amines, sorry, they're not the amines. They did the esters, they did some sort of ketone aldehyde question, they did the alkenes, they did a carboxylic acid, and they did an acid chloride. And I think the 2021 exam is what we're doing right now. In 2020, they swapped things around. They didn't do the esters, and they didn't do the aldehyde. Sorry, they didn't do the esters in that case. And then this year here, they didn't do the litmus test. So you can see each year, though, they do some sort of identification question. So you do need to know all of them. All right. The other important thing about the identification test is making sure you go through each one of these bullet points for each one of the organic compounds they want you to explain, because there's going to be points in each section of that answer. The other thing to keep in mind is what two things they've asked you to compare. Other ways they ask this question is, instead of having you compare two things, they might give you a list of 4 different things and ask you to compare them as well. This is actually a little bit nicer of a question because they've actually separated it out, so you don't have to be so overwhelmed. You do need to have those identification tests memorized because they're not providing you any hints in this case and what to use. So keep that in mind, that you need to kind of work in both directions, functional group what identification test do I need? Here's an identification test. What is it used for when it comes to what function group it will test positive for? So you need to go in both directions. All right, so first off, we have propanal chloride. So again, knowing our namings and what that tells me acid chloride. I personally like to annotate all the different kind of bits and pieces so I know then what I'm pulling as information. Propanamide, that tells me it is an amide. Cool. Do you want me to go through all of them and just do identification of what function groups they are? Let's do that. All right, second question here is propanal, so that's my aldehyde. And propan-2-ol, that is a secondary alcohol. It's going to be important to distinguish between primary, secondary, and tertiary because we can use different identification tests for them. And the last one on the bottom, I can see that's methyl ethanoate, so that's my ester. And then propene is my alkene. Are we good so far? Okay. So next thing is I go through each one of those lists and I think, okay, what do I need to do for the identification? So we need the reagents and the conditions. So when we say and conditions, we are talking about does it need to be acidified, does it need to be heated, that sort of thing. Observations then, we are talking about what do we observe with that identification test. Is there a color change, that sort of stuff. So basically the observations help us identify what is positive versus a negative result when we're trying to identify something. Reaction type, used to distinguish each pair. So we're talking about, is it like a neutralization reaction? Is it an oxidation reaction? Is it an addition reaction? That sort of stuff. And I'll talk about what each one of those means. And then the structural formula of any organic products. So making sure that we're writing, another way they ask that is by providing equations. All right, keep going. All right, so I'm actually going to use some different colors so that way we can figure out what's going on with each molecule. I'm just going to do a shorthand version of the answer. I'm not going to write it in like really nice formats. I'm just trying to show you guys how to go through each step. So acid chlorides, when I think about the reagent I need, I look over here on my sheet. Now remember, they're not going to provide this for you, so you're going to have to memorize these guys. If I look for acid chlorides, I can see that they react vigorously with water. So it's a very violent reaction and it releases a lot of heat. So if I wanted to identify my acid chloride, I would add water and the reaction would be violent. So basically it would like bubble up, it would release a lot of heat. It's quite an intense reaction. And that's how I would know if I added water to something, it would react that way. If I added water to the amide, nothing would happen. So we've gotten our reagents down. There isn't any conditions that are specifically needed for that. It just needs to add water. Next thing is the observation. So we talked about, we've already talked about the observations. And that is that violent reaction, no reaction. So we've done that. The type of reaction that's going to happen and the formula of any products. I'm actually going to talk about the equation so that way we can understand what type of reaction it is. So when I add an acid chloride like propanal, CH3CH2 C double bond O Cl, and I add H2O to it, what's going to happen is that the chloride is going to be removed and hydrogen is going to replace it. And then my byproduct is going to be a carboxylic acid. So that is what's going to happen. So we're having what we call a substitution reaction. And that's because we are substituting the Cl for hydrogen. And if I wanted to confirm that this is an acid chloride, what I could do is, if it was added to litmus paper, this would turn blue litmus paper red. So that's what I would be looking at for my first reaction. Questions, concerns, comments? Are we okay? You guys have a second? Next one? You guys ready? Still see some writing. So basically with the amide, there's not going to be a way I can identify it. Looking at this list here, yeah, there's no way that you can identify the amide. So you're basically figuring out the amide based off of process of elimination. It doesn't react. All right, keep going now. Aldehyde and alcohol. So lots of different ways we can identify those guys. The first thing that we have to keep in mind is there's lots of different ways we can identify an aldehyde. We can identify an aldehyde by using dichromate or permanganate. We could also identify an aldehyde by using Tollens reagent. What happens with Tollens is that it will make a silver mirror on the glassware. It's really pretty. I should find a picture of it so you guys can see it. Let me show you. Tollens reagent. So Tollens reagent, oh, perfect. When we add it and there's an aldehyde, it's going to form a silver mirror on the glassware. So it's a really pretty kind of reaction. You guys have done the dichromate and the permanganate before when we did redox last year. Other things we have are Fellings and Benedict solution. That one has copper 2 as the ion, and that one will go from blue to red. So we got a red precipitate forming in that. So those are 3 ways to identify the aldehyde. There are, I should say 4 ways because we have 2 with the dichromate and the permanganate. When we're looking at the dichromate and the permanganate, why would I not be using this as my identification test for the secondary versus the aldehyde? Any ideas? Why would that not, even though it would work, it wouldn't be able to distinguish the 2? Any ideas as to why? Does the secondary alcohol also react with dichromate and permanganate? Yeah. So we see here that the dichromate and the permanganate would also react with the secondary alcohol. So if both the secondary alcohol and the aldehyde are going to react, I shouldn't use this because that's not going to help me distinguish them because they're both going to result in a positive. So I need to use either Tollens or Fellings or Benedict's to figure that out. So we would use, you can choose any of them. You only need to do one of the reagents. So you can say that we're going to use Tollens, or you could also say you're going to use Benedict's or Flelling's. All of those would work. And we would see a positive result for the aldehyde. So depending on which one you choose, you're going to explain that color change. So with Tollens, it would be silver mirror forms. For Benedict's and Flelling's, if you're using that, you would say it would go from blue to red as the color change. That's our observations. You would get a negative result for the secondary alcohol. So this would stay colorless. And Benedict's and Flelling's would stay blue. So basically telling us that there's no reaction. So that gives me the reagents, the observations, the type of reaction that is occurring here. In this case, we are talking about an oxidation reaction. Which we talked about before. So what happens is that the aldehyde can be oxidized to the second step, which is a carboxylic acid. So what I would say then for bullet point number 4 is the product, in this case, would be propanoic acid, CH3, CH2, C double bond O, OH. Whereas if we look at the secondary alcohol, it cannot be oxidized any further. So, it won't be oxidized by those reagents. And I'll make another side note here. You cannot use dichromate or permanganate because both molecules would react. Or you cannot distinguish. Sorry, gotta move that over. Questions, concerns, comments? It's a pretty straightforward question, I think. It doesn't really require all that much thinking. You just need to know your reactions. I'm gonna pause the recording. You guys need some time to write. All right. Last one we have is an ester and an alkene. Esters, if we look at our little sheet over here, we identify it by the smell. It's going to smell really, really nice. And that's how I would basically figure that one out. The alkene, if we're looking at this guy over here, I can see that we have bromine water for the alkene. So we're going to use Br2, which is bromine water. And it's aqueous, so it's mixed into the water. So with the bromine water, what is going to happen is for the alkene, the bromine water is going to change from an orange color to a colorless color. I shouldn't say colorless color. It won't have any color. Whereas with the ester, there would be no color change. And in fact, looking at what we have ester-wise, it'll probably form 2 layers and it'll be insoluble with the bromine water. And that's because the methyl ethanoate will be nonpolar, would be my guess. So we would probably see 2 layers in that case. Would be my guess that's happening. We'll double check the marking schedule. All right, so that's step number 1. Step number 2 is done. So now we need to talk about what type of reaction it is. Again, what I'll do is I'll show you what reaction it is based off of the equation. So first thing I have is propene. So that's propene there. So we have a double bonded oxygen, 1, 2, 3 carbons. When I add the bromine water to it, what's going to happen is the double bond is going to break and a bromine is going to be added to each of the carbon molecules. So that's what the orange color was. Since the bromine's not there anymore, the orange color disappears. We good so far? All right, the type of reaction this would be an addition reaction. And the reason why is because we are breaking the double bond and adding to the molecule. Thus, the name addition. And that's how I distinguish between everybody. Like I said, this is the exam question I got last year, and it's not too bad. Can't see anything. Do you need me to close the blinds? Do you want me to like zoom up anymore? You're okay. Yeah, sorry. That's better. All right, while you guys are working on that, I'll pass out your practice questions and have a look at what you do with this. I'll put the marking schedule too, so you guys can see the breakdown. The next question. You're gonna pass this out like that, all right? All right, show you the marking schedule? Question? No? All right, let me show you guys the marking schedule so you guys can see how the points broke down for this question, and you can see what I'm saying. It's not too bad. NCEA Level 3 Chemistry exams. All right, we want the schedules. And we want the 21 organic. Here we go. That's some report. There we go. Schedule. All right. So that was question number 2. Just want to show you guys how the points broke down and how like easy it kind of is. So we see, like I said, we were adding water. We're doing a substitution reaction. I stated what was produced. It reacts violently. Propanoamide would not react. Poland or Benedict's, those were your 2 choices. Identified that they're the same carboxylic acid it's forming. And then bromine water, addition reaction, showing the product methyl ethanoate would not react. There's also another way that you could have done this with potassium permanganate. So if we're looking at the achieved merit and excellence requirements, achieved is just getting 2 correct reagents and observations. It is worthwhile to take a guess and give everything a go because you just need to get 2 out of the 1, 2, 3, 4, 5, 6 molecules there. All right. Other thing was 2 correct reaction types. Again, take a guess, go through each one of those bullet points and go, I think this reaction is addition. You may or may not be right, but at least if you take a guess, you have a chance. And again, 6 chances, only 2 of them need to be right. Pretty good odds. And then the last one is 1 structural formula correct out of the organic products. Again, take a guess. In this case, you only had organic products for 3 of them, so a chance of 3 times for that 1 point. For the merit, you needed to have 2 pairs of compounds distinguished with 3 reagents, observations, the type of reaction, structural formula. Do you see what I'm saying? Make sure you're going through the bullet points and that you are ticking off each one of those bullet points. So basically what that is referring to is that you got 2 out of the 3 comparisons done. And then for the excellence, you needed to have all 3 of them done. And with those 3, you need to have all those bullet points ticked off. So ticking off the type of reaction, the observations, and the products. So you really use those bullet points. When you don't use those bullet points, it's going to limit your answer. But you can see here, again, like I was saying with organic chemistry, not a hard assessment because you don't have to do a whole lot of writing. You just need to be able to know what's going on. So these are easy excellence points. Questions, concerns, comments? All right, I'll show you guys the question that I want you guys to do. So the question that I've given you guys to try is from the 2020 exam. There's a naming and drawing, and then there's a distinguishing between B and D. I've given you guys a blank piece of paper on the side so you can do your kind of scribbles with that. So that's that one. This one on the back is kind of a hybrid of the identification and the isomer kind of question, I would say, because they've given you an organic molecule formula, and they want you to figure out what the unknown molecules are. You guys can do all the bullet points with the exception of this last one here. So hold off on answering that one. I will go over that in my clarifications. Cool. Ready to give that a go? Ready to give that a go? Okay, give it a go. All right, we want 2020. And we want question. What question is that? 1. Cool. All right, here's the assessment schedule. All right. For the first question, this is what you had with the naming and the drawing. It's only an achieved point. Every so often they like to give a merit point for it, but in this case they haven't. It's just the achieved. And you just needed 2 out of the 4 correct. The next one was asking you to compare and contrast B and D. And this is where the identification and really can snowball if you get it wrong. So B was a ketone and D is an aldehyde. If I misidentified the ketone, say, for example, an alkene, gentlemen, that answer is going to snowball and affect the second one because you're going to misidentify it and you're going to justify it incorrectly. So you need to have these guys memorized properly. This one only goes up to the merit level, which is fair enough considering it's only 1 comparison. Lots of ways you can get the achieved. The first way is identifying the correct reagent. You have so many reagents that you could use because you could use the toluenes, benedicts, phthalings, and the dichromate and the permanganate because this is not an alcohol, so it will be able to distinguish the 2. Any of those 5 would be accepted. Second thing is the second bullet point, lots of different ways you can get that. Correct observations, correct reaction type, or correct product would have given you that achieved. So what I want you guys to keep in mind is with those bullet points, take a guess. Take a guess on the color, take a guess on the type of reaction, take a guess on the product. Even if you're not sure, take a guess because there's usually an achieved point there if you get it right. In this case, depending on what you chose, that would be your observation. Merit point was the full justification, so basically getting all those bullet points right. Cool. All right, and then we skipped that question. We went to C. This here is the answer to the molecule. So some things to keep in mind when you're decoding that molecule. Let me get back the camera. So first off, pulling apart the formula and what it tells me. I can see there's an oxygen there. So I think about my functional groups that have oxygens in there. That would be like an aldehyde or a ketone or an alcohol. I wouldn't say carboxylic acid and I wouldn't say ester because there's only one oxygen there. Okay. Next thing I check is the ratio between my hydrogen and my carbon. If it's ×2 or ×2 + 2. That gives me an indication on whether or not there's a double bond present, and that can help me figure out molecule. I see that in this case, it has 5 and then there's 10, so it's just a ×2. So that tells me that there's a double bond. So if I was to narrow down my choices, something with an oxygen and a double bond, I could have a C double bond C with an OH, an alcohol, or I can have a carbonyl as my functional group. So that's how I narrowed it down there. All right. I can see from the bullet points, they're going to give me some hints to help me figure out functional group. It tells me it rapidly decolorizes bromine water. And from that hint there, that tells me there's a C double bond C. So it must be this combination for my functional group. You see how I did that? Okay. Next thing on here is that it exists as enantiomers, optical isomers, but does not exist as cis-trans isomers. That gives me a hint on where the double bond is located. It also gives me a hint on how we make our chiral carbon. So basically, I need to create a molecule that has 4 different things attached to it. So when we look at the marking schedule and we're trying to figure out what we see, this here shows the alkene. It doesn't form geometric isomers because it's on carbon 1 and 2, and I have 2 hydrogens on carbon 1. So that tells me no geometric isomers. Sorry, no geometric isomers. The other thing I am looking for is a chiral carbon because it can form optical isomers. This carbon right here is my chiral carbon. It basically tells me that the alcohol is on carbon number 2 because if it was on carbon number 1, I would have no chiral carbons. This one has 1, 2, 3, 4 different things attached to it. That's how I figure out molecule S. Once I have molecule S, I can then figure out everybody else. So P, where did my camera go? P is just the product of the acidification with potassium dichromate. It doesn't react with Benedict solution. So again, that should be a hint to you that it's not a primary alcohol. Those 2 hints together tell you it's secondary. And they just want you to figure out the product. So basically, you're just drawing the molecule that is a ketone. I'm just going to swap it over to show you guys the answer. So we replace this OH with the carbonyl. Now, I want to talk about what product U and V are because we haven't had a chance to do that yet. So it reacts with water to form products U and V is the major product. Let me explain what that is referring to because we haven't talked about Markovnikov or Zaitev's rule before. So when I'm looking at this molecule, let me get the original S down. Cool. So what I have here, this is molecule S, and we are adding water to that molecule. When I add the water, I am adding a hydrogen, and I am adding an OH to this organic molecule. Now, when I do that, the double bond breaks, and I have the opportunity to add the hydrogen onto carbon 1 or onto carbon 2. So there's two possible products when I do that. If I have it going to product 1, I would have the 3 hydrogens on carbon 1, and then the OH would go on carbon 2. So that's one potential product that I have. What I could also do is these guys could be added in the opposite orientation, and carbon number 1 could get the OH, whereas carbon number 2 gets the hydrogen. So there's two possible products there when I add my water. The hydrogen goes on carbon 1 or the hydrogen goes on carbon 2. Are we okay with that as an idea? All right. So with that, we are going to be, I gotta remember if it's Markovnikov's or if it's Zayt's rule. I think it's Markovnikov's rule. So the rule goes that the carbon with the most number of hydrogens is more likely to gain the next hydrogen. So when I look at these two guys, this one has 2 hydrogens. This one directly attached to the carbon has 0. Is what that's referring to. So 2 versus 0. So stating Markovnikov's rule, the one with the hydrogen is more likely to gain the next hydrogen. So this is my major product. This is my minor product. So I'm going to have more of the major product. So major product is V, and then minor product is U. There is some SciPad pages on this. I'll look it up in the book if you guys want some more practice with that. Okay, so that's Markovnikov's rule. It's a level 2 context, which you guys wouldn't have done. All right, cool.